So he just asked me about this number 3 on your take-home quiz. It says to find the area bounded by these curves. And so I think it's important to understand what the boundaries are. The boundaries are, it says find the area bounded by the curves, and then the curves are y equals 0, which ain't much of a curve. It's just the x-axis, actually, right? Y equals 0, the x-axis. Y equals 2 square roots of x, and y equals 8 minus x. So I think in order to calculate this area, you probably need to do an integral. You know that. So you can probably get partial credit if you do this. No, I'm kidding. But you're probably going to set up an integral. Now, who are you integrating? Well, maybe it's not too clear. Which function should I integrate? Or do I integrate both? Or what? And also, what are my bounds? Am I going from 0 to 3? Or, you know what I mean? What are my bounds? You know, so there's a lot of things I need to figure out. And I think the way you figure that out is with an awesome sketch. So you need a good picture. So that you need a picture of this region. See, I'm asking, I guess the question is find the area of the region bounded by these curves. So anyway, y equals 0 is this curve. A graphing calculator would help you. You could type this in your graphing calculator. You would get this curve, something like that. This y equals 2 times the square root of x. This is just a line. You could, I think it hits at 8 here and it goes down here. I think it hits here at 8.
Yeah.
So I just know a little bit about lines. I'm sort of plotting points in my head. You know, I do this kind of quickly, and I've just got a ton of experience, so I can quickly graph these graphs and sort of see what's going on. You might take a little longer or use your graphing calculator, but if the result is this picture, if that's okay with you, and I think the area would be, and sometimes students will shade the wrong area here, so you got to pay attention to the region that has these boundaries. So if you've got this boundary, and this boundary, that's this and this and this, I think it's this region.
Right.
Okay.
Right.
Again, you might have assumed that, but I've also seen students assume this. You know, so this is, you know what they do wrong here? This would be this would be x equals 0. You know, if x equals 0 is a boundary, that's this boundary. Anyway, we didn't have x equals 0 as a boundary. We had y equals 0 as a boundary. So anyway, there you go. So, you know, what you integrate is whoever's that top curve. And so when I look at this region, who's the top curve? Is it this curvy guy here called y equals 2 square roots of x? Or is it this straight line here called y equals 8 minus x? Which one is it? Which one is my top curve? That's a bad question, really. Which one is my top curve? The answer is both of them are. Thank you. And so really I need to integrate both these guys. And so integrating both these curves is going to require 2 integrals, actually.
Right.
So we're going to split this region up, probably right here where they intersect. We're going to split this region up, and we're going to integrate from 0 to whatever that is, from 0 to whatever that is, and who am I integrating then? The 2 square roots of x, dx. Then I'm going to do another integral from whatever that is to 8. You with me? Whatever that is to 8. And then who am I integrating? The line. Right, you guys?
Right.
So that might be all I need to tell you. You're good now for number 3. You just got to finish this. Oh, but there is one crucial part. What do you need? What do you need?
That middle point.
You need this. Yeah, you need this.
Yeah.
And you know, you could call it the point of intersection of these things. That's what it is. It's the x value of the point of intersection. So you could work on finding a point of intersection. You could set them equal to each other and do some algebra. You could maybe look at your graphing calculator if it's a good looking picture, and if it came out nice, maybe you can see what that is on your graphing calculator. But sometimes it's hard to trust that calculator.
It's 4.
You think it's 4, right.
Yeah.
If it's a nice number, maybe it's easily seen on your calculator. He said it's 4. Right. Here's another thing. If you think it's 4, then what I would do is this. To sort of double check it using a little algebra, I would say, okay, well, if it's 4, let's plug a 4 in there. What's the y value?
4.
4. Let's plug a 4 in there and find the y value.
4. Yeah.
Square root of 4 is 2 times 2. That's 4.
Yeah. So yeah, you're right. This point of intersection is 4, 4, and this x value I was looking for was 4. And now
You got that.
that's a 4, and that's a 4. Are you following me?
Yep.
You integrate this function from 0 to 4. I mean,
Yep.
again, at some point, you guys, you see these integrals and you see these pictures. I mean, that integral with that curve from 0 to 4 is this.
Mm-hmm.
I mean, it's just obvious. I mean, it's just, I don't know. You understand the concept of area under a curve from 0 to 4, the area under that curve. And then from 4 to 8, the area under the other curve. And all together, we'll get the total area. So that's a good problem. I know, I mean, it's really not that hard, but it started off with that little twist being, oh, there's 2 tops. So you had to do 2 integrals. So I'll stop there and let you finish. Any other good questions? Yes, ma'am. 7 on the take-home quiz. 7 on the take-home quiz. Ooh, that's a rough one. That is rough. That is rough. 7 on the take-home quiz. It's just an integral, but it's kind of rough. 5 plus 3x.
Oh, yeah.
And by the way, you know, my take-home quizzes tend to be tougher, rougher problems. Do you agree?
Yeah.
I mean, that's part of my strategy. And I mean, my in-class quizzes are a little more basic questions or medium questions, and then my take-home quizzes are a little more medium to harder questions. So you got a week to do them. You can figure them out, I hope. Yeah, this one's just going to take a lot of, I don't know, what do you think? Anybody got any ideas?
U-substitution.
All right, thank you. Right, I mean, it doesn't fit some standard formula at all. I need to do U-substitution. So what do you think U ought to be?
2x plus 9.
All right, good. That's good. You understand some about U-substitution. If you understand that, I mean, you need to, that's the first thing to understand is U tends to be the thing inside something else. So I think I'm going to let U be what's inside this square root. So U equals 2x plus 9. I agree. All right, so you tell me the next step.
du equals 2dx.
All right. Tell me the next step.
You divide by 2 or multiply.
All right, all right, all right. Thank you very much. Thank you very much. You right? This is the game you play, right, you guys? You let U equal something. You find du. A lot of times you solve for dx. And then you try to replace all this stuff. Go ahead. Yes, ma'am.
Do we have to solve for x?
Yeah, we do.
Okay. Right. Yes, we will. I was kind of like pretending I didn't know that yet. But you're right. I mean, I was just acting like, I don't know, so far this is good. But you're right. Watch what happens when you start to replace all this stuff. Okay, let's work on the stuff we know. Down in the bottom, I got a square root of u. Do you agree with that? All right. Okay, that's that. What about this dx? What's this dx? 1/2 du. I'll pull the 1/2 out and put the du out here. So now I got this numerator. Okay, what's this numerator? 5 plus 3x. Well, that bothers me. I mean, what the hell's x?
Right.
I mean, I can't have x's mixed with u's. When you do this change of variable game, this u substitution game, you're changing all the x's into u's. And so this is what makes this problem slightly advanced, is that I got these extra x's that didn't get taken care of here. So how do you take care of it, or how do you get rid of this x? And she just said it. What'd she say? You got to go back to the original relationship here and solve for x in terms of u. And it makes it a tougher problem. Right. Let's see. I'll move the 9 over. I'll divide by 2, and that's my x. Do you agree with that? So when I go to replace this, I'm going to replace it. If you don't mind, I'm going to do that. I'm replacing this x with, is that what it is? U minus 9 over 2, yeah? U minus 9 over 2. Okay. Good luck. You guys can finish it. No, I'm sort of kidding.
Yeah.
But, I mean, this is complicated U-substitution. You with me? Started off basic, but it had that extra x that we needed to solve for and replace. So now it's all replaced. It's all in U's, and it is a doable integral now. We can do it, but your algebra skills are what's going to help you finish this. I mean, I would, maybe I'd distribute the three halves, maybe. I would combine like terms. What are you going to do with this? Well, maybe bring it up and call it u to the negative a half, and then distribute it through.
Right.
Yeah, and then you got to separate u's, and you can finally integrate. So there's several algebra steps before I'm ready to integrate. There's several clean-up algebra steps here before you can integrate. I could help you with them, but do you understand my direction so far? Are you guys okay? And then how y'all do this algebra, you know, it's kind of up to you, but I mean, I don't know. Like I said, what would I do? I would sort of think of this as a 3 halves, and I would distribute it, I think.
Right.
What?
Could you leave the 5 plus 3 and pull a 1/2 out to get
See,
the 2 out front?
Here's a problem. So you're allowed to pull multiplied constants out front, and students screw that up. I warned you about that on your other quiz the other day. You screwed up a little bit, taking out 5s and 1 4. So anyway, do you have a constant that's multiplied by everything? If you do, pull it out. So this 1/2 that you're sort of talking about, it's multiplied right here. It ain't multiplied by the 5, though.
Correct.
I think that's what you were talking about. But so I can't pull the 5 out. First of all, I can't pull the 5 out because it's added to something else. There's no 5 here. So is there a multiplied 5 by everything? No, there's not. Is there a multiplied 3 by everything? Oh, it looks like there is a multiplied 3. Wait a minute. It's not here. It's not multiplied by the 5. So no, there's not a multiplied 5 by everything. There's not a multiplied 3 that I can pull out. No. I don't think there's anything else to pull out. I think I just got to clean up what's there. And my suggestion is, I'd sort of pull this 2 out right here. I think of it as a 3 halves times the u and times the 9. Is that okay with you? So I have 5 plus 3 halves times the u. And what is 3 halves times the 9? 3 halves times the 9.
Maybe 27 halves.
Negative 27 halves. Jeez.
Right.
So now it looks like that. And I did my algebra my way there, if you can follow me. So now what?
You have to multiply by u to negative 1/2.
You did say let's move this dude up. You're right. But also there is a couple of terms I could combine there.
Oh, yeah.
That's a 5 over 1. You can combine it with the 27 halves. I mean, this is a lot of work, right? Here's my 3 halves u. What's 5 over 1 minus 27 halves?
Negative 17 halves.
Negative 17 halves. Thank you. All over this square root of u. I think I'll move it up and call it u to the negative a half.
Right.
So I did a few moves right there. Can you handle 3 algebra moves in one? It's like a triple cheeseburger. 3 patties all in one.
Okay.
I don't know how many moves I did there. You guys okay? Any questions? We combined a couple like terms. We got a common denominator. We made that 10 halves minus 27 halves. That's what we did. 10 halves minus 27 halves. That's what we did. We moved him up. Now what? Do you know what to do now?
Distribute that u.
Distribute and then integrate. Like I see this mistake often. Students get right here and then they integrate and integrate. And that's so bad. It's so bad. Why is it so bad? Because nobody ever said you're allowed to integrate a product. You can't, if this is multiplied by this, you don't integrate each thing. You don't integrate products like that. You don't integrate products at all. So you unproduct it by distributing it. So yeah, distribute first, then integrate. That's a common phrase because you do not integrate a product. So you distribute first, then you integrate. All right, here we go. Distributing. You're going to add exponents. You're going to get 3/2 to u to the 1/2, I think. And then this is 17/2 u to the -1/2. Now what's interesting is this whole time I've been doing this, I did my U-substitution, and then I've been cleaning, and keep in mind, I haven't integrated yet. So this integral symbol is still here. It's still saying, when you're ready, please integrate. When you're ready, please integrate. When you're ready, please integrate. By the way, I think I'm ready now. So now I'll integrate. So in the next step, I won't write the integral symbol. The 1/2 is out front, and I'm ready to integrate. How do you... u to the 3/2, is that what you do? And then you divide by 3/2, which is, or multiply by 2/3. It's kind of cool because there's already a 3/2 there. So if you have the 3/2 there and you multiply by 2/3, they're going to cancel. Minus, what's going on here? You got a 17/2, and what are you about to do? Add 1 to this. Add 1 to this. So that's u to the 1/2. Divide by 1/2, which means multiply by 2. Dude, we're done. Plus c. Ta-da! We're done. Well, we're done, except for the inauguration. I mean, the cancel the 2's and the 3. I mean, we're done. Just what do I have to do? What do I have to do to really be done? Oh yeah, plug back in my u. What was my u? 2x plus 9. Yeah, you're right. So here we go. That's a 2x plus 9 to the 3/2. Right? This cancels. This is -17. And it is my u to the 1/2. Is that what it was?
Yeah.
Oh, -17. The 2's canceled. So that means I just did this problem for you, or with you, or whatever. Right, that's not the end of the world. That's a hell of a creative U-substitution. But see, you guys got the hard part way back at the beginning, or maybe not. Maybe the algebra is the hard part. You know, you guys you're different kind of students. You have different. I thought the hard part was figuring out how to substitute this in. But she said that early. She said, don't you have to solve x in terms of u? So anyway, we got it substituted early, and then we just had a hell of a lot of algebra to do. You know, that's kind of the theme of this course. I know it's called calculus, but your algebra skills sure are beneficial. Yes, sir.
Would it be okay to distribute the 1/2 before you plugged everything in?
Yes, sir. Anything else? Yes, ma'am.
Number 8.
On the take-home quiz. So, okay, that's cool. Oh, yeah, that's classic. 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 Everything's classic. Is that what I call it? Everything's classic. This is a good one. You guys, let's see. Pretend, what is that? E to the 5x?
Yeah.
6e to the 2.5x plus minus 3. Minus 3. Thank you. Dx all over
e to the 2x.
All right, listen. So let's pretend this for a minute. This is your problem. I am a robot and I obey every one of your commands. So tell me whatever you want me to do. I'll do it. Within reason.
Put e to the 2x over under each one. Redo
Ooh. All right, I can't help it. I mean, I'm trying to be a robot, but I gotta talk. I gotta communicate.
Separate them and do e to the 2x under each one of them.
Okay, so there's a lot of, you guys are all kind of saying the right thing, but maybe a little bit in different ways. You know, just subtly speaking, I wouldn't really call that long division,
No.
but that's okay. I'd call it short division. But anyway, I definitely would divide. But I wouldn't do a long division thing. I would divide, because it's just one term in the denominator, I would divide each thing. It's kind of, I don't know if you remember this, but back in 5.1, some of our earliest problems kind of look like, kind of look like this. And how would you do this? You would split it up. He says split it up, but guess, you might say long division, but technically it's short division, or it's him divided by him divided by him divided, right. Split up your numerator over your single term denominator. If it was an x plus 3, now I would call it long division.
Yeah.
Now I would call it long division. But without the plus 3, I would just kind of call it short division. Just divide every term. Anyway, that's exactly what I want to do here. I want to divide the e to the 2x into each one of those, and I'll have 3 separate little problems. I'll have 3 separate terms. I mean, right now it's one big term. But the idea is you're allowed to integrate separate terms, so you want to get separate terms. So I can write this step, or I really prefer to do it in my head. I mean, what's e to the 5x over e to the 2x? What is that when you put him over him? It's e to the 3x, right. Okay, let's move over here. What happens when you put him over him? You guess you'll subtract exponents?
6e to the 0.5x.
6e to the 0.5x, I guess, because you're taking 2.5x minus 2x. You're subtracting exponents if you're dividing by like bases. And then finally, that's a 0.5x. What about over here?
Minus 3 over e to the 2x.
So it's a 3 over e to the 2x. I don't want it to look like that. What do I want to do?
U-substitution?
Well, no. Well, I want to move it up and call it 3e to the negative 2x. I mean, maybe that's what I did with all of them. But then maybe I called him e to the negative 2. Jesus. See, that algebra, you can do algebra so many different ways. You know, and I sit up here and I try to tell you what my way, but y'all might have different ideas. So here's another idea. Take this e to the 2x, move it up at the very beginning. It's an e to the negative 2x, and then distribute it.
Oh. Yeah.
Move them up, call them an e to the negative 2x, and then distribute it. Well, it's the same exact thing I just did. Okay, the result is the same. Anyway, now what?
Integrate.
Thank you, integrate. And to tell you the truth, it's 3 separate little integrals.
Right.
And maybe you need to do U-substitution on each little baby one. I mean, again, see, you should take advantage of the fact that you are allowed to integrate separate terms. And taking advantage of that means you got 3 separate little integrals to do here. And they're easy integrals. I mean, how do you integrate an e function? It's himself. But you got to know that there's this little baby U-substitution going on, and y'all were good at this the other day. So if I said, we're doing a little U-substitution on this, and we're going to integrate it, you could tell me the answer, couldn't you? 1/3 e to the 3x. You totally did that in your head. You did all the U-substitution in your head, and you know it spit out a 1/3. Good job. If you don't know that, take the time to convince yourself. Or ask me to take the time to convince you. I swear to God, that's what... Do you need convincing? If you're doing e to the 3x, u equals the 3x. What's du? 3 dx. What do you do with the 3? Move it over, call it 1/3 du equals dx. When you replace all this, this is e to the u. Do you agree? E to the u?
Right.
And then what is the dx? 1/3 du. I pull the 1/3 out front, I put the du here, and then I integrate e to the u. E to the u is e to the u with a 1/3 in front of it. And what's u?
3x.
So I don't know. I was worried you needed convincing, so I just tried to convince you of why it spits out a 1/3. All right, so let's move to the next one. So the next one has a 6 in front of it. I'm going to do a little u substitution on that. That's going to spit out a 1/0.5. This spit out a 1/3. This spits out a 1/0.5. So what's that, a 2?
Just 2. Yeah, that confused me.
And then it's e to the 0.5x. What about this one? He has a 3 out front, and then I'm integrating that. That's going to be himself. What does it spit out? A -1/2. A -1/2. Is that okay with you? Plus c. So we're done. I guess I just did that one for you too. But these are good. You know, I'm worried if I do them for you, they don't sink in as much. They sink in better when you struggle for days and weeks and figure it out yourself. It sinks in better. When I just do it for you and you say, dude, thanks, it doesn't sink in that good. So, I don't know. Yes, sir?
Could you write down the trig identities for the integrals so I could write them down?
Well, maybe. Or do you have a book? You can look them up in your book.
Yeah, not on me right now.
What was the question?
He wants me to write down a bunch of rules for him. I prefer you go look them up. I'm not a rule writer-downer, unless I'm in the mood. I mean, what are you saying? You want to know the integral of sine? You want to know the integral? You want to know the integrals of the trig functions? Is that what you're asking?
The specific ones where it's like for number 9, it's 8/√9 minus 4x squared, and you.
Oh, that.
Those.
Okay, that's those are the arc trig functions. That's up in 5/8, and
Not all of them.
and there's 3 of them. There's 3 of those big rules. I could write them down again, or you could look them up again, or. That's okay. I don't think I want to write them down again. I wrote them down the other day. They're in the book. Anyway, it's cool. I'm running out of time a little bit. But is there anything else? Yes, sir.
Can you do one of the long division problems, like number 5.7, number 19?
Maybe.
I don't even know if that requires long division. Is it if the top is bigger than the bottom? The top.
If the degree of the numerator is bigger or equal to, actually, than the degree in the denominator.
Yeah, so 19.
Yeah, so 19. Yeah, that's okay. I could do that one. Anybody got any other thing on their mind?
I would request 26. And if you have time for 29, just
Yeah, those are good.
like I know how to do them. I got the right answer, but like when I look it up to check it somewhere else, like it's kind of different.
Yeah, they might be different.
Yeah, there's probably like 2 possible answers.
Yeah. All right, so his first question was 19, which was x to the 4th minus plus x minus 4 over x squared plus 2. Plus x minus 4 over x squared plus 2. And he's right. When you notice that the numerator has a higher or equal to degree than the denominator, we ought to do long division. Let's try it, I guess. And I think, I don't know what you want help with, but you might want help with all of it, but you might want help with the long division. The long division, now, one thing about this long division is it helps to have sort of these placeholders. This is x to the 4th. There is no x cubed, but it might help for me to write that. I don't know.
Yeah.
Maybe that's kindergartenish. But I'm writing these placeholders here because it kind of helps line things up. But here we go. You know what I mean? There's no x cubed, there's no x squared. I'm just putting them in there to help me line this up. Here we go. Does x squared go into x to the 4th? How many times?
X squared.
X squared times. Because x squared times x squared is x to the 4th. Now, x squared times the 2 is a 2x squared, which would line up here. And then you subtract. Because you subtract, this is gone. And now you subtract, so this comes down as a negative 2x squared. I guess I don't really need this. This is a negative 2x squared because I subtracted. This is a plus x minus 4. Here we go. Does x squared go into negative 2x squared? Negative 2 times. Negative 2 times x squared is negative 2x squared. Negative 2 times the positive 2 is a negative 4. When you subtract, this guy is gone. Subtracting a negative is gone. So is this guy. When you subtract, he's gone. But I'm left with x minus nothing, so I'm left with an x. Does x squared go into x? No, it doesn't. So that's my remainder. I write my remainder over my divisor. Sorry. So there you go. That's the long division process, which is an important process. But it's algebra. I haven't done any calculus yet. What I'm going to do now is rewrite this integral. Because I did the division, the new integral, I mean, this answer to this division is sitting right here. It's the quotient. It's the answer. And it is x squared minus 2 plus x over x squared plus 2. And so I got to do this integral now instead of this integral. I mean, it's the same integral. It's the same. The integrand got changed into this. And now I do it. And again, take advantage of the fact that you can integrate separate terms. So integrating him is one little integral. Integrating him is a separate little integral. And they're easy as hell. Integrating the third one takes a little work. But it's important, I think, to think of it as a separate one. I don't want to lump this in with this crap. I want to do separate integrals here. Are you with me? I think students might lose sight of that sometimes. Here's the answer. 1/3 x cubed minus 2x. Oops. And then I got to finish this. I got to do this integral. You see what I just did there?
Yeah.
I sort of partially did it. I did him, and I'm waiting to do him. I did him. Now I'm thinking about this one. What are your thoughts?
U-substitution.
U-substitution. That's a good thought. That's always a good thought. Most often a good thought. U equals
X squared plus 2.
the denominator. Du is 2x dx. Are you happy to see that x dx? Yeah, because this has an x dx. So this problem turns into a 1 over u, I think. Now let's think about this. I'm saying it's a 1 over u. What's that circle stuff there?
X dx.
Oh yeah, I gotta move the 2 over. That's a 1/2 du. Okay, that's good. That's kind of basic medium U-substitution right there. That's good. We're done. Does anybody know how to integrate 1 over u? It's the natural log of u with a 1/2 out front. So this problem ends with this stuff plus 1/2 the natural log of x squared plus 2. You can follow this. Well, that's fun. I love helping you guys with homework. Love it. But I can't do it forever. I gotta quit. Why don't we quit and take a quiz? I guess I'd really like you to spread out. You guys are really crammed, and we got a lot of